Welcome! In this project we are going to use multiple lights to create some sort of interesting animated display. So it could be something inspired by Christmas lights, although probably not as in-depth or advanced as that. Or it might be displayed, it might be something else like the disco floor lights that John Travolta's dancing on here. Either way, our actual project's probably going to be a little bit simpler, but at some point in the future, you could use an Arduino to set up something pretty cool at home in terms of decoration. So hopefully there's a lot of creativity in this project and a lot of freedom to do what you like. And I'll just show you some suggestions of ways that you can set things up. For this project, we'll be using an online environment called Tinkercad. If you Google Tinkercad, it is the first result here. Now you should be able to sign up or sign in with your Google account. Once you've done that, if you click on Create and Circuit, because Tinkercad also lets you do other things which we won't be doing, you will go to this view here. Now, just a brief introduction, we have this workspace on the left, and on the right-hand side we have all of these electronic devices. We will be primarily using the Arduino, which is a small microcontroller chip on a computer board that can be used to write computer programs that control electronic devices. You can also drag on other things that you might need for your project, such as lights, resistors, and switches, etc. And you can, by left-clicking, wire up different components and connect them into electric circuits. You can also write code for the chip on the Arduino by clicking on the code button here. We will be using the text rather than the blocks, and the code will be written in a language called C++, which is fantastic for running very, very fast on low-powered, inexpensive chips like the Arduino. Your project should auto-save without you having to do anything. And if you want to change the name for what your saved file is, you can do so up here. So let's get started. Make sure you're logged into Tinkercad and get a new circuit. I'm going to rename mine up the top lights. And we're going to need some basic things. So we will need an Arduino. And we will need a breadboard. I'm going to use a small breadboard still because I'm not going to have too many lights. However, you could use a full-size breadboard. It works the same way if you wish to have a very big setup. Now, just a few things to consider before we start. Every LED, I'll grab an LED. Oh, and a resistor, I forgot. So every LED will need a resistor in the circuit. And the resistor, if we click on it, will change this to ohms, and it should be 330 ohms roughly. And let's just start by talking a little bit about lights. So as you will remember, the positive side is the anode, is the longer or the bent one. I'm going to just spin it round so that's on the left here. And if I put it in the breadboard, I can connect, we'll just start with the 5 volts. I can connect the 5 volts to this here, and I can put it into any one of these other 5 holes, and that will connect, because these are all connected, to the anode here. Okay? This side needs to be connected to ground. Now, if I change this to black, because the negative polarity is usually black, a really cool way to do this is to get the ground, and I'm just clicking to make sure that's nice and neat, clicking where I want corners, and you can realign nicely. If I connect up this whole negative line here is connected to each other, and that now means that I can just connect the negative side directly to that rather than to a ground. Because if I'm going to have a lot of lights, I won't have enough grounds here to connect to, and it'll be very messy. So that's a good way of connecting to ground. If I want all of this to also be connected to ground, I can just connect around like this as well on that side of the board. And now all of this is ground and all of this is ground. So here I could just connect this down to ground or up to ground here. But don't forget, I'm also going to need a resistor. So the resistor here can come before or after the light, but I'll need to connect this up to here. Remember, these are all connected. So this up to here and this one up to ground, for example. Okay, so let's just look at what's happening here. We've got the 5 volts coming in, connecting to the anode. The cathode connects to this side of the resistor. This side of the resistor connects to ground, and we've got our full circuit. And if I start the simulation, here we have a red light. Now, one more thing I want to show you before we finish up is you can actually put more than one light in parallel with each other if you like. And what that means is I could have a light here and I could Control C, Control V, I could have another light here, and both of them will be controlled by this wire. So if this wire is put into digital pin 2, if I turn on pin 2, it will turn both of these on. So you won't be able to control them individually, but you will be able to control them in parallel. And what in parallel means is the power comes in to this strip across these 5 holes. It then goes in parallel across both of the lights to this strip and then through the resistor. This will not work if you daisy chain them together, right, like this. I'll just show you quickly. Okay, so if you have the circuit go through one and then through another one and then through a resistor and then through the ground up here, they'll still go on, but they'll get half the voltage because the 5 volts is split over the 2. And if you did it with 3 or 4, very quickly they just won't turn on at all. So if you do want lots of lights that all turn on with a single command, run them in parallel like this. Okay, so run them in parallel so you can have one wire, 2 lights if you wish. Okay, and to just show you what that looks like as a circuit, you can see here we have a circuit. This one has a switch and it doesn't have a resistor, but imagine that's a resistor perhaps. If you run one light and then the other in series, they will all get a lower voltage, whereas if you run them in parallel like this, they will get the same voltage. Okay, so the time has come to work out how you're going to set up your lights. And you can change this as you go, obviously. I'm going to keep mine kind of simple. I think I'm going to have 2 parallel lights, and I'm going to have 4 lots like that of 4 different colors. Okay. Now, if that's the case, I don't want this wire going across here. So what I may actually do is I may turn this like that. Oops. And those 5 are connected, but it doesn't connect to these 5, so I can safely hop over here and then that can go down to ground. And I'll just check that that works for me. Okay, it does. So now I can have a similar setup. And in fact, if I go Shift, 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 Control C, Control V, then I can actually have multiple ones like that. I might leave 2 between. Okay, now I accidentally left 1 between there. Okay. So now if I hook all of those up to ground, okay, and I'm going to delete this because we're not going to be connecting these to the 5 volts. We're going to connect them to these pins so we can control them and make some animations with them, or make some, I don't know if that's the right word, make some flashing patterns. Okay, so we've got that connected. Let's have some different colors. Let's make these ones, I might actually go with a Christmas theme. But you may do as you please. And we need to have a really good numbering system. So when we're writing the code, we want to be able to think about what number pin would make the most sense. Now, I usually don't use 0 or 1 because they connect to something else which can interfere. So we could use 2, 3, 4, 5. And so what we might do is we might take this, and I'll change the color of this in a minute. Try and keep it as neat as possible by clicking to make corners. If you're actually doing this, I suggest you do this to start off with on Tinkercad, but if you do this on the actual Arduino board later, the wires are just going to go everywhere, so it will be probably a disaster, but that's fine from an organizational standpoint. I'm going to make this gray because I really don't want it to take away from the wiring. This one I might see if I can just maneuver around like I'm drawing on a circuit board to 3. Okay, and this one, okay, get this one to 4, and this one, oh, what am I doing? Okay, I'm reasonably happy with that. So 2, 3, 4, 5. Okay. Okay, let's go and check whether this actually works. So we'll open up the code. Now we'll go to text because we want to write in C++. And I'm going to delete these comments because, in fact, I'm going to delete this too because we don't need it. We can use this pin mode though. We need pin modes for pins 2, 3, 4, and 5 to be set to output because we are outputting voltage to the lights. So we'll say pin 2 to output, and then I can Control C. Oops. Now remember, this function here, the setup, happens once at the start of the Arduino running. So when we want to set the pin modes at that point, if I Control C, Control V, I can do both of those. 2, 3, 4, and 5, all set to output. Okay. Now if I start the simulation, nothing will happen. But if during setup I was to turn one of these on by saying digital write, pin 2, so that should be the first one over here, pin 2, and we'll say high because it's high and low. High means 5 volts, low means nothing basically. And if we start that, there we go, it started that. If we said 3, we'd started 3 instead, that should be the next one. Okay, so that's looking pretty good. All right, well, we've got our basic setup working. You might like to make a really big elaborate one using all 13 pins. Good luck if that's the case. I'm going to stick to something a little bit simpler here. So let's think about a pattern that we could do. Maybe one pattern is that it sort of flashes across from one side to the other. So these light up, then they turn off, then these light up, then they turn off, or whatever, and it goes through all of them. So it goes through pins 2, 3, 4, and 5. So what we would do is we would digital write to pin 2 to high, and then we would delay a short amount of time. So there are 1,000 milliseconds in a second, so maybe we'll just do like 200 or maybe 500 milliseconds, that's half a second delay. And then we want to turn that one off and the next one on. So we would set digital write pin 2 to low, and then we would digital write pin 3 to high. And I'm going to utilize copy and paste again here. So we would turn 3 to low, and then we'd turn 4 to high, 2, 3, 4, and we need 5. Oops. So 4 and 5. Okay. Okay, there we go. So we could speed that up a lot. We could do 200 milliseconds instead of 500. Okay, so that's one particular pattern that we've got. Okay, now I don't want to lose that pattern, so I'm going to do what's called a block comment, and if I do a / and a star, and then the other way around at the end, a star and a /, it means that that code won't actually run, but it's still there because I'll use it later. So that's one particular pattern. If I was to copy that, another pattern that I could do is I could do the same thing but without turning them off each time. So I'm going to get rid of these lows here. And now when I run that, the same thing, but they all stay on as they go. I could also have this one, and then, or I could have the 2 reds go on, and then the 2 greens go on. There's so many different patterns that I could make. I'd like you to just play around with making a couple of patterns that you like, and make sure once you've tested it, you just put these block comments around them, keep them all, and then in the next video, I'm going to show you how we can organize this a lot better. Okay, so hopefully you have a couple of patterns designed that you like. And what I suggest we do is we actually take each of these patterns and put them into a function. And that means in this first one, we'll have to think of a name for each one. This one here, left to right, I might call that, I might just call that left to right. But what I can do is if I copy the code, so Control X, go down to the bottom of the code here and make my own function by typing void left to right. Now a function name can only have has to be all one word, so I've used underscores instead of spaces. Void left to right, and then if you put these brackets, it indicates you're making a function. Now a function is just a block of code with a name, and you can use it at any time. So it's like packaging up that code that we used. So if I put this all in here, like this, that means that won't actually happen on startup. It'll happen whenever I copy and paste this into the code higher above. So like I said, it's a set of commands that you're going to give the computer, and the way that you tell it to do that at any point is its name followed by these brackets. So let's go up here. I set it up the pin mode, and then I just type left to right, and when I hit start simulation, it will do that pattern. Now, this other one here that I had, I'm going to make a function out of that as well. And I'm going to call that one left to right sweep. I need to call it something a little bit different because it's very similar, but it deletes or turns off the previous one as we go. So I will paste that in there. I'm just tapping it in a bit further to make it more obvious. That's inside there. Okay. Now, I probably also need to make a function that turns all the lights off that I can use in between those things. So I'll make another function called all off. And that will be, there won't be any delay in this one, it'll just be instantaneous. But I will just digital write them all to low. So pin 2 will be low, as will pins 3, 4, and 5. Okay, so what you should probably do is come up with all of these different patterns, give them names, turn them into functions here, and then you can use those patterns that you've created to set up a really nice display. And I'll just show you what I mean by that. So in this loop that happens over and over again, if I say all off, then left to right, then we'll do a delay because of maybe 200 milliseconds, and then all off again, and then left to right sweep, and then, well, it'll then go around to the top again. And you start to get the patterns. Now, there is a little bit of fade out time when the electricity stops going to an LED light. That's actually a lot more noticeable like on this simulation than on the actual hardware. But we might like to put in, again, a bit of a delay. You'll notice with Christmas lights there's often a big delay, so let's do 500. Might be a bit more obvious what's happening. Yeah, I think for me, on the ones where it actually turns them off each time, we probably need a greater delay. Otherwise, it just looks really weird. So let's try that. Okay, and maybe a greater delay in the actual loop as well. Maybe like a second between each pattern. We'll try that. Oh, I actually realized what I probably want is probably a bit of a delay after the all off as well. Now, what I'm trying to show you is not to copy me. I'm trying to show you that I can't talk and type at the same time. I'm trying to show you that you should really spend quite a bit of time just tinkering around with making it look the way that you want it to look. So that's looking now much more like what I want it to look like. Now you might make 5 or 6 of these, or you might make 10 different patterns that you can use to sort of be creative and loop around in there. Anyway, I'm sure you'll come up with some fantastic patterns, fantastic ideas.